Okay, I'm going to begin the limits test for Khan Academy, limits and continuity. Okay, find the limit as x approaches negative infinity. So we have the limit as x approaches negative infinity of this radical expression. So the highest power is 4x. So we're going to divide everything. Okay, so first let's start with the denominator. So we have 4x plus 5. We're going to divide all of this by x. So this goes to 0 because the lower power is bigger. Divide this by x. This simplifies to 4. And then now we have the square root expression. 4x squared minus 3x. So since it's negative, it's going to be divided by negative square root of x squared, which is the same thing as x, basically. So it's negative square root of x squared. So the outside is negative, and then this goes to 0, and then this goes to 4. Then we have minus square root of 4 is 2. So then we have negative 2 over 4 is equals to negative 1 over 2. So minus 1/2. Okay, so now we have functions g and f are graphed. So it looks like we have a composition of functions. So find the limit as x goes to negative 3 of g of f of x. So f of x, okay, as x goes to negative 3. So let's start with the inside, f of x. So the limit as x goes to negative 3 of f of x. Okay, so over here, x goes to negative 1, 2, 3. It looks like the limit is not going to exist because there is no, the left and right hand sides don't equal. It's not equal to the limit as x goes to negative 3 of the right, as you can see. So I don't believe this composition is gonna exist. So the answer would be D and E. Okay, so limit as x goes to pi of tan of x. So okay, so let's just see. So for theta equals pi, we have cosine. It's basically here. So cosine is negative 1, sine is 0. So tan of pi is equals to sine over cosine. So sine pi for cosine pi. So sine of pi is 0, right, over negative 1. So this expression equals 0 because 0 over negative 1 is just 0. Okay, so the function g is defined for all real numbers except for x is equals to negative 4. So what is a reasonable estimate for the limit as x approaches negative 4? So the limit as x approaches negative 4, we can just so it looks like it's going to be slightly below on both sides here. Looks like it's just slightly below negative 5, so maybe something like minus 5.2 or something like that. Let's see. Okay, and yeah, it looks like we do have that. Which of the following functions are continuous for all real numbers? Okay, so continuous, it means the left and right hand sides are equal. So the limit of x from the left hand side, limit of x from the right. I know 1 over x is not going to be continuous because we have a discontinuity at x is equals to 0. And now ln x, I think the same thing. Like, you can't have negative numbers. So let's just say we have ln of negative 5. I don't believe that's going to exist. Yeah. So I think we can also, just to make sure, we can just graph these functions and then see. Yeah, I don't think either of them are going to be continuous. Yeah, that was right. Okay, so another one of these infinity problems. So find limit as x goes to positive infinity of 2, and we of this, and then we have 2x squared. X squared is the highest power. So let's start with the denominator. Okay, okay, fine. 2x squared plus 7 over x squared. This goes to 0. This becomes 2. And now the top minus 4x cubed plus 5x. Oh yeah, automatically, my calculus teacher made me show the work for I had the test. But if you don't have to show work like that, you can just see that they have the same powers, so it should be -2. But if your AP calculus teacher makes you have to do it like the calculus way, like mine recently did, then I guess then you have to show this method of dividing by the highest power. So let's see. So x cubed over x cubed. This becomes 0, and then this becomes -4. So -4 over 2 is in fact -2. Okay. F of x is equals to x over 5 sine x plus 1. Set the correct description of the one-sided limits of f that x is equals to -1. Okay. So for theta equals, okay, so I guess first step, let's just see x over 5 sine, and then -1 plus 1 is 0. So for this spot, at 0 we have cosine is equals to 1, and sine is equals to 0. So we have x over 0, and then -1 right here. So I guess what we have to do is let's find the left-hand side first. Let's find the left-hand side. Okay, so sine of. Also, let's draw the sign in positive. So all students take calculus. This will help us, I think. Okay, so sine of 0, but slightly before, slightly to the negative of 0. Right. So that would be this way, right? Because that's a negative. That'd be like negative, like 0.0, negative point, like 0, like 9 or something like that. So I would just honestly plug in 5. So that should be a negative. So it should be, okay, fine. So it should be -1 over some negative number, right? No, -1 over 0 negative, which should be, I'm thinking this would go to negative infinity, but we can plug into 5 sine of minus point. Actually, wait, no, that's actually wrong, I think. So it'd be -1 from the left plus 1, and then -1 from the left is basically minus 1.01, something like that, right? So then, okay, so yeah, that would be negative. Okay, fine. So it would be x over negative 1 over 0 negative, which should go to positive infinity. But I'm just going to check this. I like to just check it using the calculator. So negative 1.01 plus 1, and then we have negative 1 divided by that. Yeah, so this should be positive infinity. So x is going to be, from the left-hand side, will be positive infinity. Okay, and then I'll just also show the work for this. I know that they're not going to be, I'm pretty sure they're not going to be equal to each other, but let's just confirm. Okay, so now we have negative 1 plus. So that's basically minus 0.99, something like that. So then we have negative 1 plus 1, 1 minus negative 1 plus. That's basically going to be equal to 0 plus, right? So then negative 1 over 0 plus will be equal to negative infinity. Because that'll be slightly over here. That'll be in the first quadrant. Sign is positive there. So this whole thing is positive. So it's negative over positive, which is negative infinity. Okay, so 5 sine. Yeah, so negative infinity from the right-hand side and positive infinity from the left-hand side. So it looks like we have a table, reasonable estimate for the limit as x approaches 3. So let's check it from both sides. So as x is approaching to 3, it looks like we have like 10 maybe, 9.99, 10, something like that. So we're increasing, then we're decreasing from 10. So it looks like the limit as x approaches 3 of f of x will be around 10. Okay, so the limit as x goes to 0 of 2 of g of x. So let's just find the limit as x goes to 0 of g of x. Limit as x goes to 0. It looks like that is going to be d and e, because these two, from the left it goes to 1, from the right it goes to 3. So this is going to be d and e. Then obviously 2 times d and e will be d and e. So yeah. Okay, we want to find the limit as x. Direct substitution and other algebraic methods don't seem to work. Clicking into graph and this we can estimate the limit. We can use the squeeze theorem. Okay. Charlie suggested we use the functions g of x is equals to negative x plus 1 and h of x equals to in order to apply the squeeze theorem. So I know one function. I think for the squeeze theorem it has to be like this. It has to be the one function. So let's just say this blue function will be like this. The actual function we're looking for will be like this, so slightly below it at all times. Then we have another expression that's like the slightly below that at all times. So we're squeezing it. So it looks like here. Okay, it looks like that should be correct because this function is always above. This function is always below. Let's see. Yeah, one is one. See, if you read it, one is always below and one is always above. And then, yeah, it's both approaching 1. Does that say? Yeah, it's approaching 1. See, this color or whatever that is, purple. No, I don't know. But that color is always above our function. So h is always above f. G is always below, especially close to it. Intermediate continuous function intermediate value theorem to say the equation f of x equals 15. Okay, the solution where x is between 4 and 11. Yes, I think you can. 4, 11, 12, 23, 15 is between that. Yeah. And it says, yeah. So, okay, we know it's continuous. And the other condition, I don't know. I think I think it's, yeah. What is the other condition? Okay, yeah, so it's just a value lies between f of 4 and f of 11, and then it has to be continuous. Okay. Flow chart and ask to find limit as x approaches 6. Drag the cards below to show Caleb's path to finding the limit. Okay. Let's just try that. Direct substitution probably won't work, but let's just try it. 6 squared minus 10 times 6 is 24. So that gave me 0. Okay, and then we have 6 squared minus 4 comma 6 minus 12. Okay, so when you do direct substitution, you get 0 over 0. Okay, so let's put direct substitution first. Now, let's factor. Okay, so x minus 6 and x minus 4. All right, yeah, over x minus 6 and x plus 2. X minus 6, now x plus 2. So this cancels. And now, okay, and then we have x minus 4 over x plus 2. Then we can plug in 6 minus 4 over 6 plus 2. X equals to 2 over 8, which is 1/4. Okay, so what did I do? Okay, so we got intermediate form. So the next one should be intermediate form. All right. And now try writing the limit to factoring. So e. Let's see what's after. After factoring, try evaluating the limit in its new form. Right, so we did find the limit to be 1/4. So then the last one should be limit found, right? Okay. Oh man, what did I do wrong? It's factoring and then limit found. No? What if I just remove? Oh, did I miss direct substitution again? Yeah, okay, so you do direct substitution, do intermediate form, you factor, and then you substitute in again right here. So I forgot to put that. Dang. Okay. Okay. What is a reasonable limit for the limit of x approaches 1 from the left? From the left would be here. It's looking like it's going to 2. See? So smaller, 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 approaching 2. From the left. Right, yeah. Okay, so the limit as x approaches -1 is negative infinity. X goes to -1. No, that's not right. 3 from the right is negative infinity. So we have 3. 3 from the right would be here in negative infinity. Yeah. So let's see if any other, and then 5 from the left. So we have 5 from the left would be positive infinity, which is not. It should just be b. Which intervals must contain a solution to f of x equals 2? So this looks like intermediate value theorem, and it is continuous. So f of x equals 2 would be, it'd be here. Okay, so -1 to 0, right? Is there anything else? I think it might also be 6 to 1, right? It's going from 6, 5, 4, 3, 2, 1. But let's just, okay, yeah, so it should be -3, -1. Yeah. Which is the best for approximating limits? So remember, left and right hand side and getting very, very close. And it's x goes to -7. So -8. And it should be kind of symmetrical in a way. I don't really think the first one is, because you just jump from negative. Let's see. Yeah. Yeah, that's kind of... Okay, I think this one might be better. So slightly above, slightly above, slightly above, slightly below, slightly below, slightly below. And this is from the right-hand side, so that doesn't make any sense. So the limit as f of x equals to -4 is unbounded. I think that could be right, because it looks like it's approaching negative infinity. Is there anything else? Okay, x equals to -4 from the left. No, that's not right. Because I said it's approaching negative infinity. And then, yeah, this one doesn't make much sense. Again. No, that's actually 4 plus. No, never mind. That's 4, positive 4. So let's see. Positive 4 from the left is approaching 3, so that looks like to be correct. Over which interval is f continuous? So I already see a discontinuity, like x equals to -5. Okay, so I see it is, so let's see, 2 and 7. 2 is here, 7 is here, yeah, you can just pick up your pencil and do like that, so yeah, that looks like 2 to 7 works. -4 is 0. -4 is here, 0 is here, that looks like it works as well. Oh, what are we doing? Okay, so we know it's continuous, so I think we're just gonna have to set these limits equal to each other, right? Okay, so let's plug in. I'm just gonna... Okay, fine. So so that looks like when you plug in, fine. So what am I doing? I'm setting the limit. So x goes to -4 from the left is equals to limit as x goes to -4 from the right. And I'm solving for this equation. I'm solving for k. Okay, so let's plug in -20. So -20 plus 20, that becomes 0. So we have -4 over -20 minus plus 4, which is -16. We get 1/4. So 1/4 is equals to k. So k is equals to 1/4, right? There's no manipulation there, or algebraic. Yeah, 1/4. What? Oh no. What did I do wrong here? Let's see. Okay, so from the right hand, so this is greater than. So at x equals -4, we have k. Okay, so x equals to -20. So for everything besides x equals to -4, this is the expression, right? So then don't we need to find the limit as x goes to -4 of this? And then that must equal k. So what did I, let's see. Oh, I think I plugged in wrong. Okay, so let's see. Yeah. Okay, so -4 plus 20 minus 4 over -4 plus 4. Okay, so yeah, you have, okay, I see what I did. Instead of plugging in -20, you have to plug in -4. That was a mistake. Okay, so let's see. So this is going to give us, looks like we're going to get 0 over 0. So I need to do some manipulation. So let's try conjugates. Yeah, let's try conjugates. So root x plus 20 minus 4 times root x plus 20, and that's in the radical, plus 4 over x plus 4 times root x plus 20 plus 4. Okay, so, and then that. Okay, so on the top, we're going to get x plus 20 minus 4 squared, which is 16. That's going to be equals to x plus 4 over x plus 4 times this expression. So root x plus 20 plus 4. There's not really much space to write that. And then x plus 4 is going to cancel. So we have 1 over root x plus 20 plus 4. Okay, and then we're plugging in x equals to -4. So the limit as x goes to -4. So square root -4 plus 20 plus 4, 1 over 8, yeah. 1 over 8 equals k. Let's see if that's right. Okay. So x equals to -5. Yeah, this is going to be -5 minus 3. So minus 8 times -5 plus 4 times -1 all over 0. So that's 8 over 0 is equals to infinity. And then that's going to be DNA. Okay, looks like we're going to have factoring here. Let's just plug in 5 first. So 12. Yeah, 0 and then 5 squared. Minus 6 times 5 plus 5. Yeah, so we have, when you plug in, you get 0 over 0. We need direct substitute, so let's factor. Let's factor out of 12 from the top. You're going to get 12 over x minus 5. On the bottom, you should get x minus 5, x minus 1. Let's see. X minus 5, x minus 1. Multiply by 5, add to -1. Yeah, so this cancels. 12 over x minus 1, and the limit is x goes to 5. 12 over 5 minus 1 is equals to 12 over 4 is equals to 3. So let's just set these equal to each other, right? And see if they're equal. So log 9 is equals to 4 minus 3, which is 1 times log 9. So yeah, I think it should be yes. Okay, limit as x goes to negative infinity. Is that it? Okay, negative input. So negative infinity. It looks like we're approaching -3. Positive infinity. Right here. It looks like we're approaching 0. What am I doing? Find the limit as x goes to 2. Okay. Okay, so let's find the left-hand side first, which is this one. ln2. All right? Now from the right-hand side, it'll be 4 ln2. So the limit is not going to be equal to each other. The left and right-hand sides are not equal to each other, so the limit should not exist. Right? ln2. Left-hand side, ln2. Right-hand side, 2 squared ln2. Yeah, limits don't exist. Limits don't equal to each other, so the whole thing doesn't exist. Oh, double angle expression. What was the double angle expression? I kind of forgot the double angle identity, so what can I do? All students. That's not okay. So I know 1 minus sine squared. I can get that. So okay. So cosine squared plus sine squared equals 1. 1 minus sine squared theta is equals to cosine squared. So we have sine of 2 theta squared. That whole thing is squared. All over cosine of theta squared. Let me just plug in and see if that does anything. I don't know. Okay, so double angle identity. Fine, let's just so pi over 2 is 90. I'm just gonna so 8 from the left should be 89.9. Okay, so it looks like it's going to be approaching 4. I just used approximation method. What was it? So sine, okay, let me just remember this. So sine of 2 theta is equals to sine theta cosine theta. Okay, let me just. All right, so just remember that identity. Okay, so reasonable limit for x approaching -5. X goes to -5. That's gonna looks like a DNE. Left hand side is 6. Right hand side is -4. So h of x. Okay, let's find the limit as x goes to -1 of h of x. So we have 1 over limit as x goes to -1 of f of x. 0. So that's going to be DNE again, right? So for of h of x is -1. That's here. You have 1. Now f of x goes to -1. We have 0. 1 over 0, positive infinity, but also DNE. At x approaching -2. Okay, let's see. So it's going to be discontinuous, and the limit does not exist. No. No, none of these actually, I think. Look. Actually, no. A exists. A exists. Okay. That doesn't make... Okay, so A is correct. Look, the limit as x goes to -2 from the right is -3, from the left is 4. So these exist, but this is not correct. And is it defined? It is not defined. Is it continuous? It is not continuous. So I got just A. Okay, looks like we're going to have to... Okay, let's just see. 3... Okay, so when you plug in, I think we'll get 0 over 0 intermediate form. Indeterminate form, not intermediate form. So x minus 3 over 2 minus root x plus 1. Let's try conjugate. Two plus root 2 plus root x plus 1. So 4 minus x minus 1. So -1 times x minus 3 is 3 minus x. Okay, so I put a negative there, and then this cancels. So then -1 times this, so minus 2 minus root x plus 1. Minus 2 minus, you plug in 3, 3 plus 1 is 4, root 4 is 2, so minus 2 is equals to -4. Let me just, okay, so let me just also check this. I think, let me just... Actually, wait, so did I apply that negative? So it's going to be 2 plus square root. 2 plus 2 equals 4. I think. Or not. Okay, yeah, -4. Wait, what? Minus this. What's the negative? So -2 minus 2. Okay, -4, yeah. Removable discontinuity. So let's first see. So x equals -2. X equals 2. These are all the discontinuities, by the way. X equals 2. X equals 4. So at x equals -2, the limit does not exist. Look, these are not equal to each other, so no, not that one. X equals 2 limits are not equal to each other, so no. At x equals 4, yeah, left-hand side equals 2, right-hand side equals 2, so x equals 4 is the only one. Stop recording. Thanks for watching.